There's a video clip here I want to show you, just kind of show you how the voltaic cells or photovoltaic cells work. So let's take a gander at this.
The sun is the original source of almost all the energy used on Earth. The Earth receives a staggering amount of energy from the sun. As much energy falls on the planet each hour as the total human population uses in a whole year. Solar panels are made from photovoltaic cells, or PV for short. Simply broken down, photo means light, and voltaic relates to the production of electricity. Photovoltaic technology enables the creation of electricity using light. PV cells have at least two layers of semiconductors, one that's positively charged and one that's negatively charged. When the light shines on the semiconductor, the electric field across the junction between these two layers causes electricity to flow. The greater the intensity of light, the greater the flow of electricity. There are many sorts of PV panels, including PV tiles, which replace normal tiles and simplify the install. They can be installed onto a domestic house easily and work very simply. Any south-facing roof is suitable. The light that hits the panels is converted into clean electricity. There are no moving parts, so this is a silent operation. The electricity generated by the panels is direct current. By installing an inverter, it's converted to alternating current, so it's in sync with the mains electricity and can be used normally. The clean electricity is then fed into the mains via the fuse board. Using meters, the amount of electricity generated and used can be recorded, and any spare electricity is sold back to the electricity supplier. The amount of energy available from the sun differs depending on your location. For example, Edinburgh receives 800 kilowatt-hours per square metre. In London it's 1,000, and Madrid 1,500. Although the UK is considered to have a wet and cloudy climate, 800 kilowatt-hours per square metre is enough energy to power an energy-efficient home. You would need just 10 square metres of PV to provide enough electricity to power such a home entirely from solar energy.
All right, so hopefully you now understand how photovoltaic cells work, a little bit more details about the science behind it. I want to conclude here with wind power. All right, wind power. That's the conversion of wind energy into useful form of energy, such as using it to make electricity. The most common thing we're seeing is electricity. Wind power's been around for a long time. Wind power's been used to pump water and stuff like that. Windmills and things like that you've heard about for a long time. All right, wind power is wind power feasible? Where do you find it? Now, obviously, it's going to work like where it's windy, right? I mean, duh. So you need to find places that it's like windy. And so where is it windy? Well, this is done by the NREL, which is National Renewable Energy Laboratory, which is actually in Golden, Colorado, not very far from where we're at. And you're trying to find a place where you have good wind energy, all right? So you want to have good wind energy right here. And here is blue is your best choice. Find the windiest places in the world. Well, and that's where you're going to put it. Right? I mean, duh. So good windy area up here in Northern California, right here, and then not far from us up here in the mountains, okay, right up here, and then the windy part of Wyoming. There's a big windy area. So you're looking for blues and reds. I want you to notice something about the reds that's intriguing to you. Is a lot of the reds, you realize where the reds are? It's like offshore. So a lot of potential is actually to put wind farms offshore. One thing nice about being offshore is there's no mountains or trees to disturb the wind, and so that's a very good opportunity. Obviously, another huge choice would be down here through the Aleutian Islands of Alaska. But transmitting that, it would lose a lot of energy in the transmission, so maybe it's not so feasible. Here's actually the offshore wind farms. It's actually been popularized in Europe. They're doing it a lot more off the coast of Europe and England in particular. There's some concern about how this might affect aquatic life when they build these. I don't know. But yeah, and you can kind of see the wind potential here depending on where you live, where just from the ocean's perspective. Not so good here in the purple, and much greater when you get kind of this orange and yellow stuff right here. Off the coast of England, they got a lot of light blue, so it's kind of medium. So that's where these pictures are from. And wind power can be harnessed by just Anybody. You could actually, I've seen plans on how to turn your treadmill motor into a wind farm or a windmill that can produce electricity. It's really not that difficult. And but we're gonna do a kind of conclude with a little video clip from a guy, I think he's in Denmark, who has produced all his power with one windmill. It's pretty cool. So let's take a look at that.
The Jeppesen family lives on a small farm in Tisved, Denmark, and like most, they use a lot of electricity. But this family is part of a growing trend of folks who have vowed to decrease their carbon footprint. They create their electricity with a wind turbine.
Well, I got this windmill because I wanted to produce some electricity for our household. And I wanted to produce the electricity carbon dioxide free.
The family of 7 uses electricity like a typical household.
We like using the computers and watching the television. And we like taking hot showers like everybody else. By having a windmill, we can do that with a good conscience, because we know that the power we consume doesn't expose the environment. Now we produce electricity without producing carbon dioxide. It feels so right to take our little part of the responsibility of getting better environment. Right now the wind is approximately 5.2 meters per second, and right now the windmill is producing 4.2 kilowatt, and I will guess that the household right now is using approximately 2 kilowatt. So right now we have an excess production of 2 kilowatt.
This means that some of the electricity is sold to other households. And when it is windy, the turbine produces enough electricity for 7 other families. Their next goal is to replace one of their vehicles with an electric car.
One of our future plans is to reduce the carbon dioxide emission from the cars by changing one of the cars to an electric vehicle. Right now it's not possible to buy one of those cars because they are not at the market. But I guess they will be at the market during a year or so. And then we will change the little car for an electric vehicle. By using an electric vehicle, we can charge it from the windmill during the night. We don't use very much electricity during the night, and of course this electricity can as well be used to charge the batteries on the electric car.
Costs for a home wind turbine system can vary, but materials alone start at a few $1,000s US.
Wow, he's done a lot of work to get his windmill going, so that's pretty cool. And it's helping 7 families at least. That's pretty neat. Hey, that's just some final thoughts about energy. You know, we talked about in the last podcast about oil and the peak oil thing. And eventually we're going to reach this point. The question is, what is this date? Is this date 2020? Is this date 2050? Is it 2010? When are we going to reach peak oil? If that's going to be the case, we need to figure that out. And then, well, we're not going to be able to figure it out until it actually happens. But maybe we need to begin to think about the idea of renewable resources before it's not too late necessarily, but before, sooner rather than later. So how do we get these things on board so that they are starting to replace the energy systems that we're using now, which is burning things? Are we going to replace it with coal? There's a lot of debates about what should be done energetically in this society, and it's just an important thing to be thinking about and to be working towards. We'll see you in class. Bye.